Okay, so question 5. What is the Lewis structure of acetic acid? Okay, acetic acid has the chemical formula of CH3COOH. So first, let's find out the total number of valence electrons for this compound. Carbon has 4 valence electrons, and there are 2 carbon atoms. Hydrogen has 1 valence electron, and there are 4. And lastly, oxygen has 6 valence electrons, and there are 2 oxygen atoms, so we add that up as well. And when we sum up all of the values, we end up with a total valence electron count of 24 valence electrons. So first, let's draw our 2 carbons with a single bond. And then I'll just make one of my carbons have the 3 hydrogens single bonded. And then my other carbon, let's see what happens if we have the following structure, where it is single bonded to 2 oxygens and the hydrogen. So now let's put in all of the valence electrons and count to see how many electrons we have so far. So each bond contains 2 bonding electrons. And if you count it out, you'll see that we have a total of 24 electrons in this structure. However, in the case of carbon, it doesn't have a full octet. So we're going to bring one of the pairs of electrons down to form a double bond instead. And now, if we count out the electrons, we still have the 24, plus all of the atoms have a full octet, with the exception of hydrogen, which just has a full duet. So this is a valid Lewis structure for acetic acid. And we can kind of verify that it's correct because it contains carboxylic acid group as well. And with the name acetic acid, we know that it should contain a carboxylic acid group. That's how you can kind of confirm. And the junior tutor said that acetic acid, which is also known as ethanoic acid, is considered the most important of the carboxylic acids. A dilute solution of acetic acid produced by fermentation and oxidation of natural carbohydrates is called vinegar. Okay, so they have some background information with vinegar and how to even produce it. So to draw the Lewis structure, the first thing we need to do is to determine the total number of valence electrons. So they also got 24. And now we need to consider that the carboxylic acid component of the compound is a functional group. So by obeying the rule of octet and by distributing the total number of valence electrons around the corresponding element, we will have the following Lewis structure of the compound or acetic acid. Okay, so to check, we can count for the total number of valence electrons using the dots and bonds, and they still have a total of 24. So the solution is correct.